I'm Carol Ann Riddell.
And I'm Dr. Max Gomez. Welcome to a special edition of Science and You.
It is one of the most polarizing and headline-grabbing topics being debated today. We're talking about climate change. The majority of scientists, reportedly 97%, are convinced that climate change is real and largely man-made.
In the next half hour, we'll take an in-depth look at the causes of climate change and what science tells us could happen if we don't pay attention. For starters, perhaps more extreme weather and natural disasters. We've seen plenty of that already this year.
Looking at the Earth from space, it appears peaceful, an oasis in our own solar system. But as citizens of this planet, we all have front row seats to the true wrath of Mother Nature. A hurricane named Harvey makes its way towards Houston, where it will eventually dump 19 trillion gallons of rain over the region. Irma terrifies the Caribbean and Florida. Hurricane Maria brings destruction to Puerto Rico. Those major hurricanes were big stories over the last few months, but there's so much more. Mudslides in Sierra Leone and Colombia kill more than 1,000 people. Cyclones rip through Mozambique and Zimbabwe. Tornadoes in the prairie states. Damaging hail in Colorado. Monsoons flood homes in Bangladesh, India, and Nepal, while a 7.1 magnitude earthquake rocks Mexico City. And with wildfires in California, we have to wonder, how can we protect our homes? Can we? Or is it too late?
And with us now is Dr. Gavin Schmidt, director of NASA's Goddard Institute for Space Studies. He specializes in climate modeling. Thanks so much for being with us. We really appreciate having your expertise.
Thanks a lot for having me.
So what do the models tell us, and why should we be paying attention to that?
Okay, so put aside the models for a second.
Okay.
Let's just look at what's actually happening in the real world, right? We have records from weather stations going back hundreds of years. We have records from ocean voyages that cross the Pacific and the Indian Ocean going back hundreds of years. We've got records of glaciers in the mountainous areas on Greenland, in Antarctica, and all of these data sets, they're all independent. All of them are saying that the planet has warmed significantly since the 19th century. Right? We've warmed about 2 degrees Fahrenheit, which might not seem like a lot, but for a global planet, it's huge. The ice age that we had about 20,000 years ago, when New York City was kind of covered in ice, was about 8 or 9 degrees Fahrenheit colder than the 19th century, and now we've got 2 degrees.
That was enough to set off an entire
and that was a
age.
totally different planet. Wow. Yeah, I mean, ice from the Arctic to Brooklyn, sea level lowered by 120 meters. Totally different fauna, flora, ecosystems. Everything was different.
Let me ask you though, from these records that you're talking about, going back, hundreds of years or longer that we can look at. How can we tell that it's different in terms of warming? We can tell because we can see glaciers shrinking now.
Right.
But looking at these cores and things, how can we tell that it's any colder or warmer?
So our information about the warming over the last 100 years comes from actual thermometers.
For 100 years or so.
Exactly. And we know that the land has been warming faster than the ocean. We know that the north has been warming faster than the south. And we know that the Arctic has been warming fastest of all. And these things are very clear. You know, you can see the impacts in ecosystems, in where plants want to live, where animals are living, changes in the seasonality. All of these things are consistent with this overall picture.
But Gavin, how much of that do we know is caused by us? And is some of that natural? Is some of that, for example, I know I've heard you mention before volcanoes. I mean, that can have an impact.
So there are 1,000 different things that can cause climate to change. You know, obviously over the history of the Earth, you know, they all have. You know, we've had asteroids, we've had wobbles in the Earth's orbit, we had a snowball Earth period, we've had hothouse periods where we had crocodiles living, you know, very close to the North Pole. So
most of which humans had nothing to do with.
Most of which humans had absolutely nothing to do with. But we can take the things that cause climate change and we can calculate what the fingerprint of that change would be. Right, so in the past, you know, continents moved around, right? That changed the ocean circulation, that caused a particular pattern of change. Now, over the last 100 years, we know that the continents haven't moved very much, right? So that's not That's not relevant. And we know that there hasn't been a big asteroid, so that's not relevant. But the things that are relevant are things like volcanoes that you mentioned. The sun has cycles. It has this kind of 11-year cycle and a slow long-term trend. There are efforts that we've made. Deforestation has changed the climate. Air pollution changes the climate. Greenhouse gases change the climate. Ozone depletion changes the climate. And each of those things, right, we can understand the physics of what's going on. We can calculate what that fingerprint is. What would we expect to see if that was the only thing that was going on, right? And we look at it like it's a crime scene investigation, right? So CSI Planet Earth, if you like. And we look at the evidence, and we look at the fingerprints of all the things that could have caused it, and we match it up. You know, whose fingerprints are on the weapon, right? And you say, okay, well, if it was volcanoes, then we'd expect to see this. We don't. So that's not part of what's going on.
Okay.
The sun, we'd expect to see, you know, changes here and changes there and changes here, all in coherence. But that's not what we see. We see something very different. And what we see is the fingerprint that matches the changes in greenhouse gases, particularly carbon dioxide, methane, nitrous oxide as well.
How is the fact that we're putting out more carbon dioxide, how does that lead to global warming? What's the process?
Okay, so carbon dioxide is one of a few gases in the atmosphere that absorbs radiation from the ground at the temperatures that the ground emits radiation, right? So everything emits radiation, right? So we're radiating about 100 watts per meter squared right now. That energy is kind of being radiated out all the time.
Right.
And there are some gases that absorb energy right in that band, right? Now, oxygen, there's a lot of oxygen in this room, like 20% oxygen. Nitrogen, 78% nitrogen here. They don't. So they're basically inert.
They're kind of transparent.
They're totally transparent to this radiation, right? But there are a few trace gases, water vapor, carbon dioxide, methane, ozone, nitrous oxide, that are in the atmosphere that absorb that radiation very, very strongly. And that warms the atmosphere and it prevents the surface of the Earth cooling to space. Now, we have energy coming in from the sun all the time, right? So we're just being bathed in solar radiation, right? There's all this energy coming from the sun. And for the planet to stay at the same temperature, we have to lose that energy out to space.
So it's kind of a zero-sum game. What comes in, we're sending back out, and so we're kind of
if it was
planetary
stable,
homeostasis. We're in
that's exactly right. That's where we should be at, right? We should be in balance, but we're not. Right now, because we've put in so much more of these gases, particularly carbon dioxide, and particularly from the burning of fossil fuels and deforestation, we've made it harder for the planet to cool to space. And so the planet is warming up.
So it's sort of trapped.
Exactly. So we've increased the trapping ability of the atmosphere because of the increases in carbon dioxide, and we've increased it by about 40% since the 19th century.
Can we turn it around? Is it something, or is it sort of like turning around a ship? I mean, can we do something tonight that would actually make a difference?
Our choices as a society are to kind of either let it go, let it rip, or try and moderate how fast it's going to go.
So not stop it, but we can slow it.
We can slow it down, yeah.
But whatever we would do now, because of this inertia in the system, some of it is going to continue on going on into the future.
And that's exactly why this is a tricky problem, because actions that people are taking now, we're trying to build resilience for the future.
Right.
And so you have costs now and benefits later, and that's always a little bit tricky.
So this is a really tough question. I wish we had hours more to discuss because there's so much more. But thank you so much again for coming in and shedding a little light and helping us understand it a little bit more. And a little bit later in the show, we'll be joined by ocean explorer Fabien Cousteau to talk about climate change and our seas.
But first, more on that extreme weather. In recent months, we've seen a stretch of disastrous hurricanes decimating areas like Houston, the Florida Keys, and Puerto Rico. Are these monster storms the new normal? Andrew Falzon has more.
Here in Rockaway, residents remember Hurricane Sandy's destruction all too well, and after watching Harvey and Irma, they're concerned a Sandy-like storm could happen again. In order to get some answers, we sat down with two internationally recognized hurricane experts to see if we could clearly point a finger at climate change for the power of these recent storms. However, most experts agree that's not the right way to approach the topic. According to a paper published by the National Center for Atmospheric Research in 2012, the answer to the oft-asked question of whether or not an event is caused by climate change is the wrong question. All weather events are affected by climate change because the environment in which they occur is warmer and moister than it used to be.
It's very unusual to see 3 major hurricanes, especially 3, making landfall at Category 4 or above in just a few weeks is extremely unusual.
And Dr. Adam Sobel agrees with the statement from NCAR, science is unable to directly blame climate change for each individual hurricane that rocked the Gulf Coast and the Caribbean. However, as the chief scientist and director of Columbia University's Initiative on Extreme Weather, Sobel believes climate change will only make bad storms worse.
However, based on all the evidence we have, I think it's reasonable to say that an event like a Harvey or an Irma should be becoming more probable in a warmer climate.
And the ocean is several degrees warmer than it's ever been. Now, a hurricane is nothing more than a heat engine. It gets all its energy from the heat in the ocean. So it seems logical that if you put more heat into the ocean, you're going to get stronger hurricanes. And that might very well be a factor for some of the intensity changes we've seen in recent hurricanes.
Dr. Nicholas Koch has been a coastal geologist for over 50 years and has studied hurricane formation and their aftermath in great detail. He says most changes in general weather patterns remind him of a warning he heard many years ago at a climate conference in the early 90s.
And I asked one of the gurus of climate change, how are we going to know? Is it going to get warmer? He says, yeah, it's going to get warmer, but the climate's going to become more erratic. And that was interesting. Now look at what we're having. Abnormal rainfalls, abnormal blizzards.
Whether we can already see these trends clearly in observations is something that's more debatable because there's huge natural variability from year to year. So it's difficult to detect long-term trends. And so the scientists are still arguing about whether the predictions that we confidently expect should happen in a warming climate are already clearly visible.
Here in the Belle Harbor section of Queens, some houses still haven't fully recovered from the destruction of Sandy more than 5 years ago. However, when Sandy came ashore, it wasn't a hurricane. Scientists called it a post-tropical cyclone, while politicians in the insurance industry called it a superstorm. But the question still remains, what would happen if a Category 4 or 5 storm came to New York City?
At the present time, it's thermodynamically impossible for a hurricane of Category 5 or even 4 to come up here because there isn't enough heat in the ocean.
The only way we can really get a storm that strong is if it's very intense and then it moves very quickly so it doesn't spend much time over the cool waters.
But if we continue to heat the ocean and the front of warm water extends northward, then we have the capability of bringing up some of these big hurricanes.
And while both Dr. Koch and Dr. Sobel agree it's unlikely a Category 5 could hit New York City anytime soon, they also believe that storms like Harvey and Irma could become the new rule instead of the exception.
Based on all the evidence we have, I think it's reasonable to say that an event like a Harvey or an Irma should be becoming more probable in a warmer climate.
Joining us now, Fabien Cousteau, ocean explorer, environmental advocate, grandson of famed Jacques Cousteau, and a scuba diver since age 4, he tells us. Fabien, thanks so much for being here. Let's start out with what your most recent sort of big project, this Mission 31.
Right.
31 days underwater.
Believe it or not.
So in terms of what you did learn while you were there, what did it tell you about climate change?
One of our topics was about climate change, and what we saw was quite alarming on a number of levels. Of course, we were looking at the health of the coral reefs, which are the canary in the coal mine for what's happening in these underwater cities, especially in tropical and subtropical environments. But we're also looking at the currents and the cold water upwellings that were coming up onto the reef. Normally, this is a fairly paced activity. In our case, maybe it was unusual, but we were getting more and more of this within that month period, which shuts down the metabolism of the reef in general, and in some cases actually is quite detrimental to certain species. And that we were able to monitor for those 31 days.
Let's go back to the coral reefs for a second, as you called it, the canary in the coal mine, because a lot of people think of coral reefs as dead rocks? Is it that they become this canary in the coal mine then?
So stony structures of coral reefs, the hard corals, if you will, are the reef builders. So they build the barriers against storms and everything else. They also build these underwater cities, which are habitat for 72% of the ocean species at some point in their life cycles. Wow. And coral itself is a colony of animals. So what you see in the store when you buy this piece of coral, that's just the skeleton. Mm-hmm. That's just the infrastructure. And there's a symbiotic relationship between these colonies of animals, these zooxanthellae, and the stony structure itself. And that symbiotic relationship builds on the stony structure. Now, when you have a bleaching event, that's when you have either pollution or climate-related issue that expels those zooxanthellae. And if that happens for too long of a period of time, species dependent of course, the coral bleaches permanently, and that's when you have the decay and death of coral reefs.
I think sometimes we miss how interconnected we all are, because people would not necessarily think of that as an indicator for the health of the rest of the planet and all of us. But in fact, we rely on the ocean, so we should be paying attention to that.
Well, very simply, think about our planet without ocean. We would just be another lifeless brown rock in space, floating around. This is by far the most important element that makes our species viable. Mm-hmm. Now take on a global scale what the importance of the ocean means to us, on an economic scale, on a health level, and of course on a weather pattern level. Mm-hmm. The oceans are invaluable to be paid attention to by every single person on this planet, because it affects us in very fundamental ways, whether it be in our pocketbook or our children's health, or sometimes much worse.
You mentioned coral bleaching.
Yes.
Tell me exactly what you mean by that, because people have one thought of what bleaching means.
Right.
And what's causing that? Is that related to climate change or global warming?
Bleaching of corals is quite literally an effect that climate change has on reefs themselves. Corals and the zooxanthellae, the gametes that are around these reefs that build these reef structures, are very sensitive to temperature variations. Ah. And so as the temperatures go up or down, it either slows down their metabolism, speeds up their metabolism, and if it goes beyond their viability, mm-hmm. the polyps themselves, the fleshy stuff you see that makes them colorful, expels, and they go on a hike, so to speak. If that temperature variation doesn't normalize, those zooxanthellae will not come back to those coral structures, and therefore
that's essentially how they bleach. They lose
that's
their
when
color.
they bleach.
So they actually do physically lose their color.
Quite literally lose their color and die, because that stony structure doesn't have the nutrients that the zooxanthellae bring to it. And therefore it allows for other things to happen, like other plankton and algae growth on there. And it eliminates the possibility of them coming back to life.
And this ecosystem that was so beautifully balanced between all of these other species that you said that are living in and around coral reefs, now that's completely thrown out of whack. And do we really know what's going to happen now?
Well, you have the web of life, right? The predators, the foragers, and all that depend on these healthy coral reefs to be able to go to the doctors, to be able to feed, to be able to be housed. And if those coral reefs degrade and fall apart, you don't have those infrastructures anymore, you don't have those support systems anymore for all those different species. So the foragers can't forage, they can't find food anymore, so they go away. The predators, the groupers and such, the sharks, etc., can't find food, so they go away, and all of a sudden you have a dead ecosystem.
I have also read about ocean acidification.
Yes.
Is that related to what we're talking about here?
Absolutely, fundamentally related to climate change. So it's a little bit more in-depth because it is a chemical reaction, but essentially the oceans are not only giving us every other breath that we take in, so that generates oxygen through the plankton, but it also takes in a lot of the carbon or CO2 that we eject into our atmosphere. So it's actually a wonderful carbon sink. But unfortunately, the carbon that is absorbed into the oceans chemically becomes a carbonic acid. And carbonic acid loves to take apart calcium carbonate structures, shellfish, and of course,
Corals.
Right. So we're talking about the oceans, and the first thing I think that comes to mind with the oceans and climate change is the rise in the sea levels.
Sure.
Yes.
Melting the polar ice caps, is that having some sort of an impact on the health of the oceans? It's a lot of fresh water that's being ejected into what is normally a saltwater body, right?
Right. So solid water becoming liquid and going and seeping into these salty environments definitely changes the balance of salinity. It also changes the different currents, which a lot of species depend on for nutrition or even for migration. So there are a lot of aspects of this that are disrupting the ecosystem under that blue veneer. Beyond this, of course, as you may know, when you warm up water, water expands. So it brings up not only the fact that these freshwater systems are bringing the height of the oceans,
right.
But on top of which the water is expanding, so it further exacerbates the problem. So local communities or communities around the world that are near shore are going to be very much affected by this change in the water depths.
Fabien, your grandfather famously said, people protect what they love.
Yes.
How do you think that relates to what we're experiencing now? What do you think he would say to what's happening now?
Well, you know, it's funny, we're talking about climate change now, but I remember my grandfather talking about climate change when I was a little child, back in the early 70s. I hate to date myself.
No worries.
These are not new problems. These problems are getting exacerbated by a lot of different kinds of effects, our consumerism, our increasing population, and so on and so forth, and of course the cumulative effect over the decades. He would look at this as a challenge, of course. It's very easy to get depressed by what's going on, especially when you focus on the news and the short-term heightened news that we have. But this has been going on for years. And the challenge is this: we need to change our bad habits. And if we can do so, if we can make better decisions in our lives and encourage other decision makers, communities, industry to make better decisions for us, as consumers, we can change the course that we've set for ourselves. But it's up to each individual to make that decision.
Well said. Well, Fabien, thank you so much for coming in. We really appreciate your time and your expertise on this.
Thank you very much.
Absolutely. We move on now to a topic you may not automatically associate with climate change, our health. As Ernabel Demillo discovered, there is overwhelming evidence that climate change is already taking a toll.
Tonight, we ain't gonna sleep.
Dana Parrish is a singer-songwriter living with Lyme. In 2015, the New York-based artist was diagnosed with Lyme disease, an infectious flu-like illness passed on by ticks.
I had just been in New Jersey at a wedding, and it was an endemic area, and I realized that I had Lyme.
Her doctor gave her antibiotics, but it wasn't enough.
Over the next 5 months, arthritis pain, tingling in my joint, in my fingers and my toes, horrible anxiety, depression, and insomnia, which I'd never had before. Horrible neurologic problems. I couldn't tolerate any light. I couldn't tolerate any sound. I couldn't concentrate. I couldn't read a simple book or follow a simple TV show. And I eventually had heart failure. I had also just signed a 3-year deal with Sony. So I would say I was at the prime of my life, in a very happy place. And between about September and December, I went on to have an incredible amount of progressive migrating illness.
Parrish saw 12 doctors before finding the right one who helped her get her life back. She's still living with Lyme and is now educating people about the disease. And lately, she's getting more emails and calls. Lyme is on the rise. According to the Centers for Disease Control, 330,000 people are diagnosed with Lyme every year. And that number, they say, could be 10 times higher than what's actually reported. Scientists have warned that warmer temperatures means a longer tick season. And ticks are not our only concern. Other insect-borne illnesses, including Zika and West Nile, are spreading. Now doctors across the country are sounding the alarm. Climate change, they say, is posing a risk to public health. The Medical Society Consortium on Climate Health, a group representing 400,000 physicians across the country, released a report detailing how our health is being impacted.
Yes, climate change is a very serious issue for physicians because it's an issue that can be addressed. It's an issue that adds on to pre-existing illness, makes people more sick, makes people sick in different ways, and it's totally preventable.
The report warns of several risks: harm from extreme heat, including heat stroke and heat-related deaths; injuries from extreme weather, like major storms, droughts, and floods; polluted air, they say, has led to an increase in asthma and allergy attacks; wildfires in the West have led to respiratory problems. Meanwhile, disease-carrying mosquitoes, ticks, and fleas are spreading. The tick that carries Lyme is now reported in almost half of U.S. counties, up from 30% in 1998. There are also other concerns that many Americans may not be aware of, including the increase of contaminated water and food due to extreme weather, and the threats to our mental health from the stress and anxiety experienced during weather events like hurricanes and floods. This map shows how different parts of the country are affected. Dr. Mark Mitchell is a member of the National Medical Association, the largest and oldest medical organization representing African American doctors. They found that the population most vulnerable to climate change are children, the elderly, and the poor.
More recently, we've become concerned about the effects of environment on low-income people and people of color. In 2014, we did a survey of our physicians to find out whether they're seeing health effects of climate. And to our surprise, 88% of our physicians are already seeing health effects of climate in their patients.
According to the NMA and the NAACP, climate change disproportionately affects people in low-income communities, in most cases where people of color live. In these neighborhoods, you'll find more pollution-emitting incinerators and toxic factories.
It is our same communities that are most likely to be dumped on and contaminated by the factories and the power plants and the landfills for the production and disposal of those very excesses of materialism.
NMA is now working with the consortium to raise public awareness.
One of the things that people don't realize is the lowest income people have contributed the least to greenhouse gases, but suffer the most from health effects of greenhouse gases. Low-income people are more likely to not be able to get out of the way of floods when there's a superstorm Sandy. They're more likely to die during a heat-related event during the summertime.
Dr. Mitchell and the consortium say we can take action now by reducing our carbon footprint, whether it's policy changes on a national or state level or at home. He says we can make a difference, but we have to start now.
If we reduce our fossil fuel use right now, we reduce our pollution immediately, and we can reduce the asthma attacks, the number of children in the emergency room. We can reduce the number of children who die of asthma every year immediately. And so we have an obligation, I believe, to do that.
That's our show for today. Now we'll see you next time on Science and You.